Hello, good morning to all, and welcome to this unique live technical discussion series. So today we are going to have our a talk on design of RCC structures. So majority of you may be aware that we created a Telegram group to facilitate technical discussion for structural engineers, and you all have raised many interesting questions. And many of those questions were answered by Dr. Shah. So I was wondering, I just contacted him once, that is it possible to create a short presentation from his side wherein he can summarize few queries and then he can present. And promptly he said that definitely it can be done. And we are very much thankful for him for spending his precious time with us today. So what we have done essentially, that we have collected few questions from the group, few interesting questions from the group, and response of them is presented. And also we announced this event in social media also, and we received in fact many more interesting questions. So part of those questions have also are also covered in this small presentation. Okay, so we'll be having shortly with us Dr. Shah, and he will be responding to few very interesting queries which were raised by you either in the Telegram group or in the social media. Okay. So once again, very good morning to all of you, and welcome to this unique live technical discussion series. So I'll request all of you that please like and share this video in the relevant group so that we have a wider participation. And if you have not subscribed to this channel yet, please subscribe to this channel because we are going to increase the frequency of live session. Okay. So that if you would have subscribed, then you will receive the notification whenever we go live. Okay. So let us welcome Dr. Shah. He has just joined into the stream. Yeah. So good morning and welcome, Dr. Shah, to this unique live technical discussion series. And we are very much thankful for you for spending your very precious time with us. Yeah.
Jai Mataji, Jai Shri Krishna. Everybody,
yeah.
Good morning to everybody.
Good morning.
I am very much thankful to you for inviting me in this particular live session.
Yes.
And I will try to fulfill the requirement of this session.
Yes.
Number of questions, we collected number of questions, and from those questions, we selected a few which were frequently asked, and they were regarding the columns and many other things related to the column section. So we initially chose this column section, and accordingly I have made a small presentation.
Right.
So now, may I start presentation?
Yeah. We will just. Yeah, just one. Let us take 1 or 2 minutes so that more participants will join. Meanwhile, Olao has joined from Goa. So good morning, Olao. Yeah, good morning, Avinash. Yeah, so good morning, Janvi. Good morning, Atul Niya Bharat. So good morning, Nitin Chandra. Good morning, Akash. So I believe majority of you might be part of the Telegram group, so wherein Dr. Shah is spontaneously giving answers to so many questions. Yeah, good morning, Mohammed. Good morning, Shrikant. Good morning, Viren. Good morning, Abhishek. Okay, good morning, Tejas. So, sir, can I get manual design of RCC structure? So I think it is very nicely documented in the book authored by Dr. Shah, I believe. Yeah, good morning, Raghuram. How are you? Okay, good morning, Salman. Okay, so we have very close to now 50 participants. So now I think we can start with the presentation. And during the presentation, if you have certain queries related to the presentation, then you can mention it in the live chat, which will be taking it up say after the presentation, right? Yeah. So good morning, Rajan. Yeah. Good morning, parallel fear fly. Sorry. Okay, so this is related to IS 4561964. Okay, good morning, Naman. Okay, so now let us begin with a small presentation related to the queries. So what has been done essentially, the whatever queries which were then in the group, so few of those queries, interesting queries, were compiled, and the queries which were on which the questions were being asked repeatedly by the engineers. So few of those questions have been taken up, and on that the presentation is prepared by Dr. Ajay. So let us begin our talk today. Uh, so over to you, Dr. Ajay.
Thank you. Good morning, everybody. In our live in our Telegram group, many questions were asked regarding columns and the other means related to the columns. And accordingly, I have prepared the presentation, and I definitely think that you will like it. आप बीच में second आने questions and answer नहीं. This presentation is divided into two parts. In the first part, I will give you a small lecture where the queries are combined to present in a presentation format. And in some second part, a few questions which are asked over the social media regarding to this particular chapter that will be discussed. Whenever you consider any building, this presentation is sway and drift, effective moment of inertia, soft story and weak story, P delta effects, first order P delta analysis, second order P delta analysis, stability factor, and effective length of the column. So these topics are combined over here in this particular lecture. So now let us start with a building. When you consider a building, primarily we have two types of the loads, vertical loads including dead loads and live loads. And because of this, there will be displacement, and vertical displacement will be represented by shortening in the column. If there is a tension, there can be a tension elongation. And horizontal displacement of the columns, they are represented by means of the buckling. There will be horizontal loads also, like wind loads and earthquake loads, and for that the displacement will be horizontal, and that will be the total edge sway of the building or sway of the column. Say like this, say for example, if this particular column is subjected to vertical load, then it is, you can see there is a buckling. Now this buckling can be small, even you consider a small load, theoretically speaking, there will be a buckling. So when you consider a load to be small, this height of the smaller, then this buckling effect may be small, or it may be considerable. So now these two words are very important, considering small or considering considerable. When it is small, you consider it as a short column, and when it is a considerable, you will consider it as a long column. So here this way is shown over here. There is a building and one frame of unbraced building is shown here. The horizontal loads H1, H2, H3, H4 may be because of the wind loads or maybe because of the earthquake loads. They are shown over here. Because of these loads, there will be bending, and bending of this particular portion is shown on this side. You can see that whatever these bendings are there, D1, the displacements are there, D1, D2, D3, and D4, they are called absolute displacement because they are calculated with respect to this vertical line. But suppose if you are considering any particular floor, say for example, say story number 3 over here, then this D3 minus D2, that will give you say delta 3, and this is called the drift of the third floor, and so on. So this is the meaning of the sway. Total sway is a sway of the particular point with respect to a fixed point, whereas the drift is nothing but the difference of the displacement of the top and bottom of the stories. This sway may be small or it can be large. Similar to the buckling. Buckling may be small and may be large. In the same way, the sway also can be small or it can be large. When it is small, we can neglect it. When it is large, we have to take into design. So, how to consider it? Permissible sway due to wind loads. There are two things. When there is a sway, the permissible sway values are given by the code, and that I will read. The lateral sway due to wind at the top of the structure due to wind loads, partially load factor 1 for limit state of the serviceability, and by using effective moment of inertia shall not exceed 0.002 h, where h is the height of the building. What does this mean? That wind loads, for wind loads, the code has given the sway limit and not the drift limit. Drift limit is given for earthquake load, whereas the sway limit is given for the wind loads. So you need to consider the whole building. Say, for example, in this building, the total sway is equal to D4. This D4 should not exceed 0.002 h. That is the total height of the building. Now here the important words are effective moment of inertia and so on. So because of that, we have to discuss about the effective moment of inertia also. There are two another words that is called braced and unbraced columns. Similarly, you can say braced and unbraced frames also. Now the lateral loads are there acting on the building. They can be resisted by shear walls, bracings, special arrangements, or otherwise by any other arrangements. If you resist them horizontal force directly, then it is called braced building. The columns occurring in that, they are called the braced columns. See, for example, this particular building is there, and there are a number of columns, and you can see 1, 2, 3 on the front side and 3 on the back side. 6 shear walls are provided. What will happen that under the action of the wind load and the earthquake loads, the shear walls will be taking all the loads, horizontal loads. Therefore, the all inner columns, all these columns over here and here, external parts also here and here, all these columns are not subjected to wind or earthquake load. In other words, they are braced or they are sheltered, just like a few people carrying umbrella. So under the umbrella, rain will not be there. Outside the umbrella, rain will be there, and so on. When lateral loads are resisted by bending in the columns and beams with no help from the bracing element, then the columns are called unbraced column. These columns will sway. So if suppose you consider the second building. In the second building, we don't have any provision for the shear walls, etc. And therefore, all the columns will bend. All the beams will bend. The total load, horizontal load, will be taken up by each and every element of this building. And therefore, it is called unbraced, unsheltered. Specific sheltering is not given to them. Now here when I say braced and unbraced, then total sheltering is given or total sheltering is not given. So if suppose if you consider the sway because of the braced condition, it will be 0. When you consider unbraced, it will be maximum or the full sway will be there. If you consider the practical columns and practical buildings, you will hardly find a total braced building. How these loads are transferred? The slab is acting as a diaphragm. The horizontal loads are transferred to the vertical load carrying elements through slab that acts as a large diaphragm. Since the slab has a large stiffness along the loads, it can transfer these loads to the columns and walls in proportion to their stiffness. So when this load is applied, first of all, say for example, earthquake loads, and they are acting at the mass center, and then it will be transferred. Now the transferring is done by means of the slab diaphragm. The slab diaphragm, because of the large depth, it has a very large capacity and it can give the vertical element in proportion of that. I wish to transfer the horizontal force in some particular elements, then that also it is possible that I will make the stiffness of those elements to so large and the stiffness of the other elements so small that they will not take the loads. And this is the principle used in braced and unbraced building, that you are making stiffness of some elements so large that the other elements are automatically sheltered. Say, for example, when you are providing a shear wall, the stiffness of the shear wall in the direction of the earthquake load or in the direction of the wind load is very, very large. Therefore, it will take all the loads. Shear walls or large columns may not provide 100% resistance to wind, maybe 98%, but less than 100. So this particular statement states that as we have considered that all the loads are transferred to the shear walls, but exactly when you are calculating, because some elements are there, they have also some stiffness, though. So you cannot say that all the 100% loads are taken by the shear wall. Maybe even small, 1 or 2%, but that will be taken up by the vertical columns. And therefore, the word braced and unbraced are not exactly 100% correct for our practical buildings. So our IS 456 has given two different words, that is no sway and sway columns. No sway means there will be deformations. There will be a sway, but that sway will be limited. As I initially told you, that you must remember these words, limited and more. So either you can consider limited or considerable. When it is limited, you need not consider it. When it is considerable, you should consider it. So here in our buildings, if suppose the sway is limited, then we can say that this building or otherwise the columns in the building are acting as no sway elements. If suppose it is considerable, you can say that it is a sway building, or the columns in the building are sway columns. So instead of now telling them braced and unbraced, we may call them as no sway and sway columns, or no sway and sway buildings. Here this is a presentation of sway and no sway columns. Say suppose this is a frame, horizontal loads are also acting. First of all, this is showing a frame with no sway. So no sway means the sway might be there, but it is a considerable, limited. These vertical loads will try to buckle these columns. You can see the buckling of it. Now here buckling also can be small or considerable. So you needed to consider, say, for sway also and buckling also. So here for vertical loads, you needed to consider the buckling. So buckling may be considered, buckling may not be considered. Next one, when the sway is more, what will happen? That because of this sway, the frame will be swaying like this, and the moments are also introduced. So if this sway is smaller, you may neglect it. If this sway is considerable, you have to take into account. With the frame with no sway, sway is limited, P delta effect due to horizontal load may not be considered. What is P delta effect? That is when load is applied, there will be delta. We have considered in the very first slide that because of this load, there will be a horizontal effect. And the P delta I will explain you in the next slide. Buckling of individual column needs to be checked. If it is limited, short column, it is neglected. If it is considerable, P delta effect due to buckling needs to be considered. I am using two different delta. Say here this P delta, this triangle is used for the horizontal loads, and here this delta is used for the vertical loads. So first you consider horizontal loads, then you consider the vertical loads. When the frame is with sway, the P delta effect is considerable and you have to take into account. Even then, buckling should be checked. Many people are under the impression that when you are checking the P delta effect because of the horizontal load, you need not check this P delta effect because of the buckling. But in fact, you need to check both. First of all, you go to the horizontal loads, define the building edge sway or no sway, and then again go to the vertical loads and calculate the P delta effect of the vertical load also with the formula given by the IS 456. Again, the horizontal displacements are shown and the drifts are shown over here, just to recollect our past discussion. Now, this drift is very important in multi-storied building. Drift is here delta 4, delta 3, delta 2, delta 1. These are the drifts, and these drifts are very important in multi-storied building. So when you are fixing up the beams and column sizes, etc., you need to first of all check the drift, and if the drift is not satisfied, you need to increase the sizes. What will happen if the drift is there? There will be two main important problems are associated with drift. One is a structural damage. There can be a structural damage, and another is a non-structural damage. Drift-related investigation has shown that during earthquake, large damage potential is observed with large values of drift, irrespective design detailing of the structure. Why irrespective? Because drift is a serviceability criteria. We are separating out the serviceability criteria as well as the strength criteria separately. You have to check both the things separately. It has to be strong also, it has to be serviceable also. Some non-structural damages are there. Suppose you experience large drift in case of the earthquake, then you will say that your window is not closing. Bending of the doors are bent and you are not able to close it, and so on. So these are the non-structural damage, but it will create the upsetting in the minds of the occupants. The drift is specified by IS code in case of the earthquake and not in case of the wind. For wind, sway is considered, and for drift, earthquake drift is considered, and it should not exceed 0.004 HI, where HI is the story height. And here also it is said that using effective moment of inertia. So this we have already discussed. Now this drift we are considering can be calculated, and it may be because of the different points. Said due to rotation of the columns and girders, it is known as a bent action or a displacement drift. Due to cantilever action of the space frame, known as the chord displacement, it means the whole building is acting as a cantilever. Due to shearing action of the lateral loads, known as shear leak displacement, and second order displacement due to P delta effect. These are the four things, and a few many also you can summarize. This drift will be very high in case of the this displacement drift. I am considering about the medium rise building. Then you can see that this displacement drift will have about 80% of the total contribution on the overall drift. Presently, I am discussing about the medium rise buildings. Therefore, you may consider only one drift. Here I am discussing about the manual calculations and not the software calculation. Therefore, you can only consider the bent action displacement drift. The code also, while defining the sway and no sway column, it says that you need to consider the first order drift only. These are the second order, third order, and these are the different ways of calculating the drifts. When you are calculating the drift manually, by considering the first order analysis, and when you consider the drift by means of the software, which is taking all the points into account, so naturally the deflection or the drift given by the software is actually large than what we are calculating manually. Now, what is effective moment of inertia? When you are analyzing the building, when you are analyzing the frame, if I consider the manual calculations, what we do? We consider the frame, and we calculate the distribution factors at all joints. For finding out the distribution factors, we consider the moment of inertia of the beams and columns as 1 by 12 BD cube or 1 by 12 BFD cube into KT, etc. for flange sections and so on. Now the concrete, when you start loading, initially suppose there is zero loading, there is no crack. But when you are adding the loading so and so, just gradually you go on applying the loading, then there will be a crack starting. When the moment of inertia, the moment of this rupture will be attained by the concrete, there will be a crack. There will be a sudden crack, and then the forces will be transferred to the reinforcement. Remember that the forces to the reinforcement are not transferred without crack. So there will be a crack. And as you go on increasing the loads and moments, the crack will be definitely increasing more and more. Now what will happen? Because we are not considering the crack, this crack into analysis, the whatever the concrete is cracked should not be considered into effect the moment of inertia. Therefore, the moment of inertia of the beam or a column will be reduced. Now this reduced moment of inertia is maximum at the center, means maximum reduction will be at the maximum bending moment, and lower in the lower region. It means the moment of inertia, even it is reduced, is not even constant throughout the beam. Suppose I want to calculate the distribution factor with respect to this moment of inertia of a uncorrect section, then definitely I am wrong because the distribution will not be correct. So for proper distribution, when there is a real failure because of the earthquake or because of the wind, at that time what will happen? How much cracking will be there? So to take into account that, we have to consider the effective moment of inertia, and that effective moment of inertia is given by the code. So we have effective moment of inertia of the section divided by gross moment of inertia of the section is defined as a section modifier. The section modifiers are given by the code, giving us a table like this. This table is given by the IS 16700, and it gives you the section modifiers for slabs, beams, columns, and walls different. Now here, two different things are there. One is unfactored loads and another is factored loads. What does this mean? That when you are finding out some particular properties like drift, displacements, they are calculated with respect to the serviceability conditions, because the displacement, the deflection of a beam, the displacement of a frame, all these are nothing but the serviceability conditions. And for that, we have to check it with respect to unfactored loads. When you are checking on where you are calculating the factor load, if it means limit load condition, then you are loading it for 1.5 times or 1.2 times the total loads, and then factor load will come in picture, and therefore again the moment of inertia will still decrease, and for that you have the smaller factored loads or the smaller section modifiers for that. So now it should be clear for you that serviceability conditions, these modifiers, and limit conditions, these modifiers. What does this mean? That you need to prepare the two different models. If you are using the software, then you need to prepare two different models, one for serviceability condition, another for factor load conditions. Now what is better? That you first of all create the model with respect to factor loads. It means you apply these section modifiers with respect to the factor loads, and you calculate the bending moments, and after you completely run a successful design, after you complete the successful design, then you say that yes, the model number 1 is okay, and that is what we are doing up till now. Now the same model will be considered as model number 2, and now change the moment of inertia, and again run the model for serviceability condition, and then you will be able to check for deflections, then drift, etc. So you need to provide two different models, one for ultimate load means limit load condition, another for serviceability condition. There is a tremendous confusion amongst the people using section modifiers, and therefore I have cleared it that 16700 is giving you an accurate or perfect conditions. Now when I am talking about the medium rise building like 6-story, 7-story or below 50 meters, then it is considered by the code that unnecessarily making two different models and increasing the labor work in the calculations may not be justified, or some relaxation may be given. Therefore IS 1873 says that when you are checking for drift for earthquake loading, then you may use the section modifiers for ultimate loads or the factored loads, and you find out the drift. Now what will happen? That the displacements will be more because of the lower moment of inertia. But at the same time, the code gives you a relaxation that you can use the unscaled seismic loads as obtained from the response spectrum method. Now this is very important point, and you need to be clear about this. Many queries have been raised for this. We are checking or this new code 1893 gives you that in most of the examples you will have the response spectrum method as a compulsory, because 0.4 second smaller than that means 3-4 story buildings, etc. Instead of that, we consider this response spectrum method. When you consider response spectrum method, you calculate or you find out the earthquake forces. Base shear also you can take the total base shear. First of all, you calculate the base shear and their distribution because of the theoretical condition. Then we have some scaling vector, and then we are scaling all those loads at various stories. The code says that before you scale it, you can check the drift. It means whatever the hard things are given, they say consider the lower moment of inertia and find out the displacement. So larger displacements are calculated, but the concession is given over here that you can go for unscaled seismic loads. When you multiply it by the scale vector, it becomes a scaled seismic load. And when you multiply it by the partial perceptive vector, then it will become a factored load. Please remember that first of all, in this response vector method, whatever the loads at different stories you are getting, they are unscaled seismic loads. You multiply it by seismic scale factor, it will become scaled seismic loads. And when you multiply it by partial load safety vector 1.5 or 1.2, etc., it will become factored loads. Now we need to calculate the story stiffness. And the story stiffness is, for the first order analysis, is defined by the story shear divided by story drift. I have already given you an example how to calculate the story drift, that the displacement, difference of the displacement at top and bottom is called a story drift. So this particular formula comes out to be as applied shear by story drift. That gives you the story stiffness. However, you can calculate the story stiffness by means of theoretical conditions also. Okay. The story stiffness is given by moment of inertia because it is a property of the frame or a story. So you can calculate the story stiffness by this particular formula. For derivation of this formula, etc., you can refer to my RCC volume 2, where this particular formula has been derived. And please remember, this is only for bent displacement, not other. Only one. This is used for the first order analysis. So for each and every story, when I apply this formula, then I can find out the story stiffness for each story. And when I want to find out the drift of that story, I can apply this formula and find out the drift of the respective story. See, once you calculate this drift, so what we are calculating from this? We are calculating this triangle delta 1, delta 2, delta 3, and delta 4. Now when I start from here, this is 0. Plus delta 1 will give me d1. Plus delta 2 will give me d2. Then adding delta 3 will give me d3. Adding delta 4 give me d4. So capital D1, capital D2, capital D3, and capital D4, they are called the absolute displacement. And delta 1, delta 2, delta 3, and delta 4, they are the story stiffness. The drift of the story. Now we have already calculated the stiffness of the story. So some particular terms related to the stiffness that are discussed over here. That is called the stiffness irregularity, and we call it as a stop story. Now how to calculate it? Calculate the lateral stiffness of all stories. So if suppose there is a 7-storied building, I will calculate the story stiffness K1, K2, K3, K4, K5, K6, and K7 for all stories. If an RCC shear wall is provided, it may be treated as a column for calculating the lateral stiffness of the story. Here this is for the first order analysis, and therefore you may consider this as a column. Otherwise, you need to consider some more effects also. It is necessary to say that the lateral stiffness of the story of all stories is in order. This particular word you need to remember and understand very clearly what we mean by order. In order means when I go from lower story to the upper story, say story number 1, then 2, 3, 4, 5, 6, 7, like that. The stiffness of the story in 1 should be maximum. In 2 it can be equal or lesser. In 3 it can be equal or lesser. In 4 also it can be equal or lesser. So on, means that is called in order. So the story stiffness of ith story should be either less or equal to I plus 1. That is called in order. Story stiffness in order If it is in order, it is all right. If it is not in order, say for example, the story stiffness of the third story is more than the second story, then we call it as a soft. Second story is a soft story, and the soft story should not be there as per the code. Such a situation is observed in ground floors with open story. That is no masonry fill in the ground floor. In some 3-4 story building, what we do, the ground floor is meant for the parking, and therefore we don't provide the walls. In the upper floors, we have the masonry walls, therefore they are acting somewhat as a shear wall and increasing the stiffness of the story. So we may have a lesser stiffness in the lower story like this. One more thing is there that usually we provide it, but what we do, we keep the story height lesser in case of the parking. You must have observed that the parking stories are about 7 feet high and the upper stories are 10 feet high. So this particular point we are taking into account in our design, because if I consider 7 feet height, then that stiffness will be increasing because of the smaller length. Still, however, if suppose the stiffness is lesser in the ground floor, I need to provide at 1 or 2 locations the shear walls to increase the story stiffness. So the soft story should not be there. Again, come to the story drift. Now we have already calculated KSI for every floor. So whenever you find out the V, that is the shear force of the story, you are able to calculate the delta I. This is one small example. This is a first order analysis of a 7-story frame. Now when I speak story, and there are many confusion about it. When I say I have a 2-story building, then you understand that there is a ground floor and there is a first floor. When I say 5-story building, then there is a ground floor and 4 upper stories. But when I consider, or when we calculate our columns, then we are providing ground beams or ground slabs, etc. at the ground level. So there is a column below that also, or otherwise there can be a basement also. So we consider the basement story as 1 story, or if there is no basement, then also from foundation to the plinth level, we call it as a 1 story. So that will be called as story number 1, story number 2, and so on. So 6-story building, as we speak in general, that is a ground floor plus 5 upper stories, means it is a 7-story building as far as our calculation. Now here the stories are written, the HI is written, and this is P. P is a vertical load. All columns, suppose there are 16 columns, so the sum of the all 16 column load is 6,000. In the 6-story, these are the loads, and in the first story, that is a basement story, load is very small because here there is no slab, no live loads, etc., or maybe directly transferred to the ground, and the load is only some masonry and so on. So the load is very small. In the last story, because of the terrace, the load might be smaller. Now here the delta P is sigma P is calculated for any load. The sum of this, just go on adding. So the column of the second stories are subjected to 41800 loads like that. So this is a sigma P. Suppose at every floor, every story, at the 7-story, 6-1, or the floor of that, the loads are acting as 208, 264, 252, and these are the loads. These loads may be because of the earthquake load, or they may be because of the wind loads. So they are called the loads applied. The whole building is acting as a vertical cantilever, and these horizontal loads are applied at the story level. Therefore, we can calculate the shear. So just go on adding them, just like a cantilever beam, we calculate the story shear. So the story shear of the second story is 1343. It means it is equal to the summation of all these loads. Now our simplified method, first of all, you have calculated this KSI, that is the story stiffness, from the formula that was already discussed. You can calculate the story drift by considering this VI divided by KSI is a drift. So this delta 0, why I have written 0? Because it is a first order analysis, and delta 0 is calculated for every stories. It is lesser, then it is increasing, and here now it is decreasing. Why this is decreasing? Because the story stiffness may be larger. You can see here the story stiffness, instead of 40, it has become 58.82. Why? Because the height is reduced, and therefore the story stiffness is increased. Okay, then after drift, you start from the bottom. This 1.83 is a displacement of the ground story, and then just go on adding this plus this is this, this plus this will be this, this plus this will be this, and so on. So just go on adding the drift, you can calculate the total displacement. For earthquake, you need to consider this drift. Say, for example, if there is a fourth story and the height is 5,000, 0.0404 h is equal to 20 millimeter, the drift of this story is 22.9. It means it is not satisfying the drift considerations, and therefore you need to make some arrangement on this building so that the drift is well within the limits. Similarly, the total height you can calculate over here, and then you can divide it by 500 and then check whether this, if suppose this is wind load, if it is earthquake load, then you need not consider the last column. Suppose it is wind load, you need to consider the last column and this value only. Then the total height divided by 250 and calculate and compare with 109.87. If it is less, then it is all right. If it is more, then you need to change the dimensions of the beams and columns so that it will be fit into this criteria. Suppose the drifts are not satisfied and you need to make a revision in the building. So revision should also be made step by step. The first revision you can go with a concrete grade, because if you are just going on changing the sizes, etc., then you need to consider many other things also, that you cannot change the size randomly. So first of all, you just go by in order that first of all, the lower story concrete should be richer than the upper story, and considering this, you just go on adding the richness of the concrete. So the lower story concrete 25 will be converted or considered into 30, and 30 into 35, and so on. If suppose after that also you are not satisfied, then you go on revision of the column size. Just go on adding the sizes of the column. When you are adding the sizes in the column, you must remember that the lower story should be larger than the upper story. Also, you need to consider that when you are increasing the size of the column, it should be at least constant for 4 floors. 1, 2, 3, and 4 stories, it should be constant so that the former economy is there. If suppose after this two also the drift is not satisfied, then you go for revision of the beam size. You can increase the beam size slightly, but usually we avoid this because of the criteria of weak beam and strong column analogy. Suppose you are going on, or if you are increasing the beam sizes, then the beam moments of inertia will be increased and the beam capacity will be increased, and therefore it will become a strong beam weak column analogy, and you need to again increase the size of the column or reinforcement in the column. So when you go in order, you will be able to find out the solution for the drift. We have already calculated the drift. At the same time, we need to consider the strength also. The weak story is defined that if suppose the shear strength of the upper column is should be lower, it should be gradual, means it should be in order, that the shear strength of the lower story should be larger than the upper story. So that is called a order. If suppose this is not observed, then it is called weak story. Up to this is given in the code. Now, how to calculate the shear strength of the story? Suppose there are 16 columns in the story, and you want to check the shear strength of the total story. Now, you know that to calculate the shear strength of any section, you need to calculate the reinforcement, percentage of reinforcement, and tau c. In column, you consider the tension side, means half the reinforcement, and find out the tau c. And that tau c might be different for different columns. It means the procedure is really cumbersome. At least in this particular example, what we are concerned is to consider the relative strength of the columns. So it is right, instead of calculating the percentage of reinforcement and tau c, etc., you just consider the column sizes. The presence of an axial compression to some limits increase the shear strength of the concrete, means this also you need to consider when you are exactly calculating. Now in the code itself, 13920, some formulas are given. What are the strengths you have to consider? And where I have taken this formula, that for view story, I can revise this formula like this. The shear strength is proportional to square root of the concrete grade. I can calculate FCK, under root of FCK into area for each column. If suppose the concrete grade is same for column, all columns in the story, the formula is again simplified. If suppose the concrete grade is 30 in 8 columns and 25 in other columns, then you need to separately check. So by this simple formula, it is possible to calculate the shear strength of the given story. And then again you check it. So for example is given here that if suppose there are 500 and 500 by size column and 25 grade concrete, then the shear strength, lateral strength of the story is simply 16 into under root 25 into size of the column. That is 20,000 kilonewton. Here this simplification is made because we are interested in checking the relative strength of the stories. Now let us come to the P delta effect. So when you are considering the flexible structures subjected to lateral loads, the resultant drift will also displace the vertical loads. How? See here. Say this is a story or a column. This is just a representative of line. If you consider as a story or as a column. The initially HI and VI, I means the I story. HI, VI are acting over here. What is HI? HI is a story load and VI is the story shear. We have already defined it. Because of this, there will be a horizontal displacement. That is a delta I0. This is a first order analysis. Delta I0 we have already calculated. Now this is very exaggerated sketch. Therefore, you can see this angle also. Remember that this angle is hardly 0.1 degree or even lesser than that. So what will happen? That there is a displacement of the load. The load is vertical. And you can see that this particular story is or a column is subjected to a bending moment of sigma p multiplied by this distance. What is happening again? Because of this horizontal load, there is a sway. Because of this sway, the vertical load of the column is displaced by the drift. And because of this displacement, the vertical column loads, gravity loads will induce some moment over here. Suppose this moment, whatever the moment is there, I want to balance it, then I can balance it by means of a couple like this. This is a couple. VI1 is a couple, and this couple moment must be equal to the moment induced by this. So here I have written here P delta moment is P into delta I0, that is this delta 0. Then additional shear. Now this original shear is VI, but because of this additional moment, VI1 is also added here. So additional shear will be VI0 plus delta VI. And what is the corrected drift now? The drift which was delta I0 over here. This was delta I0 here. It will now become delta here. Delta I1. You can say delta I1 here. So the drift will be changing. Now suppose drift is changing and again you are applying this load. Then also again there will be a moment. So this procedure will continue. Again you just go on correcting the drift and changing the shears. So finally what will happen? There is a VI initially. At the end of the first iteration you get VI1. At the end of the second iteration you get VI2. At the end of the third iteration you get VI3 and so on. That is what is explained over here, that over the first iteration you are getting delta VI1, and similarly with the another iteration you can get the more and more shears. Now see, if you are continuing for n iterations, you get VIN equal to VI0 plus delta VIN. Now when stop? We will stop this iteration when these two are very much nearer. It means very much nearer means what? That we consider difference of 5%. See this calculation. This is a manual calculation of the second order analysis. This is iteration number 1. The original one we have already considered over here. See, this is the original one for the same story, this building. This is a first order analysis, and we have calculated the drift delta 0. With this now, I am increasing, considering this one. This is a second order analysis. Whatever the additional moments are created, because of that, we are calculating the additional shears and then finding out the final shears. So here the HI is written, sigma P. This delta 0 is from the first table. This additional is calculated over here, this delta, and then VI additional is calculated, VI1 is calculated, and the revised horizontal drift is calculated. With this drift, you are calculating revised drift delta 1 and absolute displacement, the same table, but we are now adding this VI0 into this additional shear and calculating VI1, and we are calculating absolute displacement again. Now, whatever the drift is originally over here 5.1 is changed into 5.25 because of the additional shear, and the percentage increase is 2.93. You just go on increasing, checking this drift, etc., and the percentage increase available in the last column is summed up over here, and maximum is 16%. It is not very much nearer. So now again go for the second iteration. So you go exactly the same things, go on the second one, revise it, and go on for the second iteration and find out the percentage increase in the shear. And you can see here that the maximum is 2.37, which is less than 5%. So now we stop here for n equal to 2. And whatever the finally we have calculated this revised H here, you can see revised H. With this revised H, you can consider your building and find out the other factors or shears and moments and so on, and this percentage increase should be well within 5%. So this is about the first order and the second order analysis for the drift. Now we have already seen that we have two different moments, that is a sigma P into delta. Sigma P is a gravity load and delta is a drift. When this drift, code says that you can consider this first order drift, and that is to say this first order drift, this drift. So this sigma P and this drift tree. Suppose I am considering the story number 5, then the sigma P is 20,400 and the story drift is equal to 17.75. This is because of the gravity load. At the same time, we also have another moment, VIHI, that is a horizontal load, and HI is the height. So this is a primary moment and this is a secondary moment. We are checking for the horizontal loads. Therefore, the moment created by the horizontal load is a primary moment, and the moment created by the this first order and second order displacements, that is called the second order moment. The ratio of this moment is called the stability index. This particular thing is defined by the code. In IS 456, this formula is given, and IS 16700 also this formula is given, and the nomenclatures given by both the codes are slightly different, and it is expected that the new editions of the IS will take care for having the same kind of the nomenclatures in various codes. So the ratio of the first order to this the second order to first this primary moment is equal to stability index. Now, why we calculate the stability index? The stability index is the index of whether we consider the displacement to be within the limit or considerable. And initially, in the very first slide, I told you that you neglect it if it is less. You cannot neglect it when it is not less. So this stability index will give you whether you neglect it or not. The code says that if the stability index is less than 0.004, you can say that it is a no sway frame. If it is greater than 0.004, you can say it is a sway frame. And by definition of the brace frame, Q is equal to 0. Therefore, all the brace frames are no sway frames. IS 16700 gives one more limit. that this Q may be less than 0.004 or may be greater than this, but cannot be more than 0.2. Here we have calculated an example of just a 7-story building. But when you are calculating a 20-story or 30-story buildings, then you need to check that this Q is not greater than 0.2. Otherwise, you need to increase the sizes of the members. For the same example, I have calculated the stability indices over here. The height, sigma p, Vi, drift, and the stability index is calculated. You can see the stability index. And then you can classify that in this 7-storied building and the other columns are sway. It means when you are calculating the effective length of the columns locally, when you are designing another in the column inside, then you need to consider the columns of the 4th story, for example, as a sway column. To calculate the effective depth of the column, the code has given 2 different charts, one for the no sway and another for the sway buildings. For no sway conditions, the effective length factor is less than 1 or less than 1. For sway columns, it is always more than 1. The code also recommends that the effective length factor for no sway column, for the sway columns should not be less than 1.2. So minimum effective length factor you need to consider is 1.2. So this is a effective length of the column. This is a first part of my presentation which I have completed. And now we shall go to the question and answers. Okay.
Yeah, it was an excellent presentation. Okay. Yeah. Focusing on all, I think the practical difficulties which are being faced, like P delta analysis, stability index, drift consideration. So we have few interesting questions coming up. So let us take it one by one. Okay, Shrikant is asking that, sir, can you please explain the concept of release and fixity, that is transfer of moments in a beams?
Hello, Summarise.
Yeah, please.
Yeah. Concept of release and fixity and transfer of moments in the beams. I think you want to consider the relative moment distributions between the two.
Right.
Whether you consider fixity or not. See, when the members are monolithic, they are, instead of word fixity, I think the word framed is a more convenient one. What do we mean by fixity? That whatever the moment is created by the member fixed into the member. Say, for example, there is an RCC wall and a small beam is protruding out of that. That can be considered as fixed because all the moment will be transferred to the vertical shear walls. But when there is a joint, there is a upper column, lower column, the beams, left beam, right beam, etc. So 4 members are meeting at a joint. So we cannot say the fixity, but let us say it is a framed conditions. So according to the moment of inertia and the change of moment of inertia, the distribution vectors will be different and the distribution of the moments also will be different. So instead of fixity, we call it as a framed condition, and the framed condition will be governed by the distribution factors. Distribution factors will be again governed by the effective moment of inertia is again governed by the section modifier.
Right. Yeah. Janvi is asking that, can we get this PPT for study and reference?
I think it is the whole presentation is available on YouTube.
Yeah, it will be recorded, so, right? Yeah, so you can.
Yeah, you can, so everybody can have it.
Right. Okay, so Ejad Attarwala is asking that, sir, in software we are not providing walls. If that is the case, then how the actual stiffness is calculated?
So the stiffness of the story, I think you mean the stiffness of the story, yes. Right? So as I have already explained to you that we are considering the story stiffness in the first order analysis. Please remember, I am discussing only first order analysis. because otherwise there are many reflections we have to consider. So only the bent displacement when we are considering, we have to consider the bent displacement of the beams, displacements of the columns, etc. So this is at length given in RCC volume 1, volume 2, even present volume which also is there, and how to calculate the storage stiffness is also given. In this presentation, I have given only one formula. So from that formula also you can calculate the storage stiffness. But one point I want to tell you, that when you are calculating the beam stiffness, you needed to consider, if it is a flange, you should consider the flange effect. If it is L beam, you should consider the flange as L or T beam. It will be again become a strong beam in weak column analogy. So whatever the reality is there, you have to consider it.
Right. Okay, this is the last question which we'll take, and then we can move to the second part of the presentation. So this question is like, what precaution one may take in case of, let's say, grade slab which is supported on the swelling soils.
I think this is a question of the related to the geotechnical engineering. However, when there is a swelling soil, if suppose it is not very important, then you can mix the sand. In the soil, you can mix the sand. And otherwise, if it is possible, you can remove that soil up to certain depth and fill it with the sands. Or sometimes we mix, if sand is not available, then mix it with yellow soil. And sometimes we even add the cement also, so that it becomes stronger.
Right.
So by this you can make it stronger, and the grade slab can be supported on it.
Yes. So certain precautions are to be taken before supporting on the swelling side. So what we have a second part of presentation wherein, when we announced this event in social media, so there were many questions which were asked by the engineers. So few of them are covered in the second part of the presentation, and still what I can see on the screen, that interesting questions are floating. So I think we should go ahead with the second part of the presentation, right, first, so that we can finish it within time.
Yes, and if the support time permits, then we may take up them, or otherwise we will reply them in our Telegram group.
Yeah, sure,
right?
sure. Great.
Yeah. Should I share screen? No.
Yeah. You can share your screen now, please.
Application window on here. Yes. We got a few questions, and the questions were some of the questions were pertaining to our topic. Some of them were not pertaining to this topic, and within some particular fixed time, we have to consider all these things. So I have taken some of the questions which are pertaining to this topic. The first question is from Ajit Kurve. In many times during modeling of building, the lintel beam not take in consideration, but in practical, due to this beam, the column is become short column and increase shear force demand. What measures should take during modeling and analysis and design? And same in case of the staircase slab, level beam, and in plane beam also. Now here, when you consider modeling, and when you consider the lintels, etc. So many times lintels, we usually do not want to integrate them in the columns. Otherwise, there will be a short column effect. And because of what is a short column effect, that whatever the moments are induced because of the horizontal loads divided by the short column effects means the height, that will be a shear induced. So what will happen, that a moment divided by the short column effect, so it will give you more large shear, and the column may fail in shear. The beams also can fail in the shear. In the same way, column also can fail in the shear. So what we usually do, first of all, okay. This is the situation, I think, what you want. These are the two column, one column here, one column here. And you want to provide lintel for these three windows. It is basically, first of all, the first solution is that you have these walls and you just support this lintel over these walls. In most of the buildings, we follow this. And this masonry can very well take up the loads of the upper masonry, because the other loads of the slabs will be taken up by this beam. Suppose this is not possible and you have a building like this. You want a full story. You want a full opening. If possible, then you can just create two small vertical walls over here, and over this you can support it. Even if this is not possible, then go to here. In this case, I have provided here and here two insert plates in the column. While casting the column, we provide the insert plates. After you remove the formwork and the column is strong enough after 7-10 days, you can weld the two angles over here, and from over those angles you can support this lintel. If suppose this is also not there, then many times we have suspended the vertical bars from the upper beam and consider the lintel supported by these two suspenders. These all four things we have already done successfully on site. And suppose anything is not possible, then there is no alternative, and you need to go for short column effect. So there is no alternative. These are these four alternatives are shown to you, and if it is fit to your condition, go for that. If not, then again you have to consider it. Slide. The second position here shown here is a staircase condition. Suppose this building is a 5-6 story building, and suppose this is a staircase, and on all sides there is a slab. So what will happen at this slab level? This particular beam is there, and at the landing level also this beam is there. It means this column, this circled column, they are having a short column effect, which cannot be avoided. If suppose a building is 2-3 story, then many times what we do, from this slab level beam, you can erect masonry in 1:4 cement mortar up to the lintel level, and you can support the staircase over the masonry, provided that the staircase is a separate element. Okay, if this is not possible, then you have to provide a beam at the mid landing. It means the columns are having the effect of the short columns. In this case, what we prefer, we actually design them for the shears. And in most cases, if you go for the special confining reinforcement throughout the length of the column, it is all right. And in most cases, you can check for 2-3 cases, and you can provide the whole length of the column. After being satisfied with manual calculations, special confining reinforcement shall be provided throughout the height of the column. So if it is avoided, you can avoid. If it is not avoided, then you have to consider. Next question is how to terminate reinforcement of column on roof level. So this is a column shown over here. This is a column shown over here, and the reinforcement are taken on this side, and this reinforcement is taken on the other side, and this distance is equal to LD. This is equal to LD. So by this way, you can support the column. Now, suppose if you have forgotten the taking the length of the reinforcement up to this point, then say this is that case over here. Then you can even lap the reinforcement and stop or terminate the column like this. This is a figure from SP 34. More details you can even get from the same code. Another question is from Abhishek Singh. He wants to discuss about the floating columns. Why restrict the usage of pan India? For example, down south it may be used. I have seen floating columns being used in highly specific areas in Japan. Why are we not going in that direction? See, one thing is floating column, providing a floating column is not a crime. The crime is that when you are providing the floating column which is unengineered. And that is why the code also restricted in certain cases. You can see the code suggestion as per 1893 part 1. The floating columns are likely to cause concentrated damage in the structure and are undesirable. It says that it is undesirable. You may not provide it, but it does not say that mandatory you do not provide it. A building with floating columns shall not be permitted if the floating columns are part of the supporting the primary load, lateral load resisting system. This is because if suppose the floating column is a primarily load resisting system, then where it will provide the reactions. I have drawn one figure over here. See. Suppose this is a building and I do not want a column over here. These are all the lateral load resisting system is there. So what I can do, this column can be erected from this beam and this beam. It means I am providing a foundation for this floating column in both directions. Whatever the vertical loads are there, what are the moments? If suppose there is a X moment on the column or Y moment in the column, alternatively, they will be taken up by moments in the beams. Suppose I provide only one side beam, then what will happen? That the perpendicular moment will be acting as a torsion. Over here, this particular column is considered as a floating column and skillfully adopted that these four members are primarily lateral load resisting system, and you can provide this kind of the lateral, this is a floating column. But when I say, or when the code says that you provide the floating column, then people will try to provide the floating column as and when anywhere. Just like a slab beam, we are not able to discuss the slab beams today in large. But when somebody says slab beam, yes, it is even better than beam. The people have something in their mind that the floating column can take the load, then it can take the smaller load, 5 ton, 10 ton loads, but it cannot take 100 ton load, and you should not. And that is why there is a red light. Say, this is a red light. This is a particular building in ground floor. From that, the cantilevers are taken. In the first floor now, all 8 columns are omitted and the columns are taken outside. Now you can see that these columns are now taking the loads of 10 story above. And now what will happen that these columns are not supported by the lateral load resisting system. And then what will happen to this particular building? It has to fail in case of the earthquake. And this is not a particularly created a problem. It is a real problem. In one of the building at Ahmedabad on 27th January 2001, I had personally seen the failure of this kind of the building where the floating columns were like this, and over these columns, number of stories were supported. So the red light is that the floating column is not always a solution. As far as possible, as a good engineer, you must try to avoid it. When you cannot avoid, you can provide it only for very small loads. Next question is like this. Is read by Abhishek Singh. Load combination factors with live load reduction applied. This is a very common confusion point. This is a confusion point because the earlier IS 1893 and this one has some different things. And people, those who were acquainted with the old one, and they may not have read this clause, and therefore they will have some confusion in their mind. Now, according to the latest one, for calculation of the earthquake loads, reduced live loads on all floors to be considered as 25% for loading class up to 3 kN per meter square and 50% for more than 3 kN per meter square. This reduction is available for calculating seismic mass and used in the dynamic method of earthquake force distribution. So when you are calculating the seismic mass and what is the actual the seismic force or the earthquake force acting on the building. So up to that calculation, you can use this reduced live load. But after you calculate the earthquake loads at each story, and when you are actually designing it, when you are combining it with the dead load and live load combinations, then you need to consider the actual load. After calculating the earthquake horizontal forces acting on the building in design for all load combinations including earthquake loads, live load reduction on only columns and walls is allowed depending on floors supported by the column under consideration. Thus, this reduction will be affect the load columns and foundations. Yes. So the earthquake load reduction is now not allowed. In previous code, IS 1893 previous code, you can refer and you can see that even for the frame analysis also that load was used. So that is a confusion that people, those who were acquainted with that, and now with this clause they are confused. So now please remember that we cannot use that reduced live load for the combinations of the loads. Yes. Then the reduction of the live load 10%, 20%, 30%, 40%, and 50% for more than 10 stories is available in IS 875 Part 2. It is available for gravity loads. And when you are considering the gravity load combinations, you can very well do it. Now, suppose you go to the softwares. I do not know many softwares. I only know STAD, a little amount of the understanding of the STAD. And I at least know that the STAD software does not take into account 10, 20, 30, and 40% of the live load reduction. And it is very, very difficult to adjust in the software this percentage of reduction for designing of the column. But when you are designing the foundation, you can reduce the load 40% the loads for a building up to 10 stories and 50% load when it is more than that. So the STAD gives you, if you refer to the STAD software, the STAD foundation, it gives you one particular clause, one particular things that you can use 40% or 50% reduction also if you want. This particular question was there in Telegram once that why this software is giving me an option like this. So this option is given because the main software cannot use 10, 20, 30%, 40% reductions, but at least in foundation you can go for 40% or 30% live load reduction. So I think the confusion of many people will be cleared. So this the same thing is discussed over here, that definitely there is confusion because the two IS codes are stating the different things. Yes, I am asking you and requesting you that as far as my knowledge, STAD is not taking into account. But if suppose any other software, if this reduction 10, 20, 30, 40% of live load reduction and in design of the story column is taken into account, please let me know. Also, if any software is designing columns as per strong column weak beam analogy as per IS 13920, please let me. The STAD at present is not designing considering strong column weak beam analogy. Presently, it gives you the corrections that if suppose you are you have applied the size of the columns etc., then the STAD checks it, and at the end it gives you that this particular column is a fail or pass. But after failing, it does not give you a solution that okay, it is failing and therefore you can do this way or that way. If another software is giving you such kind of the things, please let me know. The second question is from Professor Himmat Solanki. Why ductility was not included? How the long columns behave with respect to drift and ductility? Now see, this is a very short presentation and many things cannot be included. So we limited our this presentation to certain restricted areas. Ductility consideration itself is a wide topic and was not included for time limits. The next question is, when moments due to buckling, additional moment as per IS 456 are added to the design, it is similar to the short column. Ductility requirements are also the same. See, the ductility requirements are not different for short and long columns. They are the same for both. as per 13920, no distinction is given. The next question is also from him. What is the definition of the hidden beam? In a flat plate design, column rows reinforcement 1/4 of the span can be considered as a hidden beam. Now, this particular point or this particular term hidden beam that was included in this discussion only for this reason that many people are not exactly conversant what is a hidden beam. Sometimes in earlier periods, if suppose I want to support a heavy concentrated load like a partition wall over the slab without providing a real beam, then the code says that the concentrated load should be considered on a wide area. The formulas are also given. So if you consider that wide area and provide the additional or more reinforcement into it, that is a solution of that particular example. But many people thought that they want to provide some larger or the load is something more, then let us provide a hidden beam. So what we usually do in practice, that under the concentrated load like a partition wall, we provide a small hidden beam, maybe a 600 wide and 120 thick, just a thickness. So hidden beam definition is nothing that is not visible and thickness of the beam is same as slab and is hidden in the slab. Over here, what we usually provide in hidden beam, that there are 4 number 10 dia bars at the top and 4 number 12 dia bars in the bottom, and there is again a link is there, and the remaining 2 bars also are tied by single small links, open links. They can be considered so that the shears can be very well resisted, and then people use it for resisting the vertical loads of the partition wall. When you consider beam, then beam has the same meaning as a visible beam. Hidden beam, or it may be hidden beam or it may be visible beam, the criteria of the beam are always there. So hidden beam should have a thickness equal to L by 20 or L by 26 as per the beam consideration. Now in slab you can do it, because in slab also you are using that particular criteria of L by 20. The deflection criteria is same for beams and slabs, and therefore you are using this hidden beam. Also in hidden beam we are providing the top reinforcement column, the compression reinforcement. Therefore it will again modification vector will be there, and therefore it may be there in deflection criteria. But in moment criteria, it will be definitely lagging. The reinforcement can provide the moment only for the smaller load. If you provide a larger load, then the deflection criteria will not be there. Strength and serviceability criteria. So the final conclusion for the hidden beam is that you may provide a hidden beam in this slab to resist or to support small partition loads, small loads, provided that the strength and serviceability criteria of the open beam are satisfied for that. Now this automatically says that the column raised reinforcement in flat plate cannot be considered as hidden beam because it will not satisfy the criteria of beam. No shear reinforcement, no deflection criteria, because when there is a beam, you have to provide the shear reinforcement. In the slab, we don't provide the shear reinforcement. So this will not consider the criteria of the serviceability and strength criteria of the beam. So hidden beam should not be considered as capable of a real beam. And just to clarify this point, I have taken this hidden beam into the consideration of this lecture. I think this is last. We have received a number of queries for topics other than the scope of today's topic. We are sorry for not discussing them. Also, the time constraint will not permit. Thanks to all of you for hearing me patiently. Believe me, your presence in the program definitely give us pleasure by heart. Special thanks to Bhavin Bhai for arranging this talk. Thank you. Jai Shri Krishna. Jai Mataji.
Yes, thanks a lot. Again, an excellent presentation, excellent response to all the queries which were raised. And as you rightly said, we received actually many queries which we could not cover because of limitation of the time. So now, meanwhile, there are very interesting questions which are popping in the live chat. So let's take 2-3 questions, right? And then we can close this session. So is it okay? Can we take up 2-3 questions?
Yes.
Yeah. Okay, great. Yeah, one interesting question from Olao from Goa. He's having 3 buildings which has a basement and 6 upper floors, and the basement for the 3 building is common. So hence the ground floor slab is around 1 meter by 25 meter. That is the overall dimension of the ground floor slab. Over that 3 buildings are supported. So what is this question that can we avoid the expansion joint? And do we need to apply temperature combinations in that case?
No. You should not go for that. You must provide the expansion joint. I
Right.
think when there is a separation of the buildings, there are 3 buildings, so there are 2 separations are there,
Mm,
and you can provide the expansion joint at the base.
mm,
Now, expansion joint, many times people consider like that you need to provide 2 separate columns and provide expansion joint. So
mm,
probably what you can do, you can provide the expansion joint even in the slab also. What you
mm,
do, you provide the one particular 2 rows of the columns in such a way that the distance between them is hardly 7 to 8 feet,
mm,
and then project the slabs for
mm,
3-4 feet and provide a gap of 2-3 inches and just provide a expansion joint. So I think you should go for expansion joint. So there is no alternative to that. I don't think.
right. Right. S&V engineers is asking that whenever, let us say, beam are resting on the shear wall in out of plane direction, so at that time should we raise the moment in the beam, and what is the ideal practice?
Beam resting on shear wall in out of
Ah,
plane direction. Yes,
out of
the
plane, yeah.
perpendicular beams are there.
Yes.
Perpendicular beams are there.
Ah,
So when now see, you need to say that what is the kind of that beam.
mm,
Suppose this perpendicular beam is a part of the main beam or a lateral load resisting system, or
mm,
even a part of the main beam for the gravity load conditions, then it
mm,
is better to provide a column inside the shear wall. Say shear walls we are providing as a say 200 thick or 300 thick shear walls, but at the end you can provide the stiffening elements and you can provide a column.
mm,
So the main beam can be supported by this column, and you can design this column for biaxial moment. I think that will be an ideal condition.
mm. Right. Yeah, Sujit is asking, sir, is it necessary to increase the stiffness at above and below of mezzanine floor?
So here, instead of considering above and below, you need to
Mm,
simply see that the upper column should have a lesser or equal stiffness than the lower column.
mm,
So if it is not there, then you increase the stiffness of the lower column.
mm, mm. Right. Yeah, Harsh is asking a very it's a common question which is coming from all that. Can you please discuss about torsion irregularity, specifically what to do when the structure is going under torsion in first or second mode itself, as in seismic zone 3-4, it is not allowed. So it's a big question, and of course, right, it's out of
Okay,
context of
I
today's
understood this.
discussion. Yeah, yeah.
Anyway, he wants that to say that first and second mode he is getting a
Yeah,
torsion. Right.
right, right.
Now, see, the consulting practice of an engineer definitely depends on his cleverness.
Mm,
So how cleverly you are placing the columns and shear walls, etc.
right.
So here in this case, if you are getting the torsion in the first order, first mode, that is
Mm,
not acceptable.
mm,
Definitely, it should be first mode, second mode. No, I think it should go to the third mode. And for this now, you need to place skillfully the shear walls. And that is the very important. Suppose just see how it is balancing. When you see the balancing, you will be able to exactly find out where to put the shear walls. One small common rule was there that per length, say if you consider a length of the building, and you see that in every meter or every 10 meters, the stiffness of the building should remain the same. If you consider this kind of the thumb rules, then you will get probably you will not get the torsion in the first and second mode. So you have to avoid it. You have to avoid it by providing the shear walls.
Right. Okay, so now people are just appreciating the session. They are saying thank you. So thank you all also once again for participation and making this session as a successful. Okay, and we are very much thankful of you, Dr. Ajay, for sparing your valuable time with us. Yeah. Okay. And,
Thanks.
yeah, and we will see that in future also, if time permits. Sometimes we may arrange the session on the questions which were raised on the social media. Yeah. Okay. So once again, thank you all for participating in today's live technical discussion. So we are signing off today now. Okay. So have a good day ahead. So bye from our side. Yeah.
Thank you all from my side also. Thanks
Yeah.
to Bhai also. Thanks
Yeah.
all the people who are participating. And some of the questions which we could not take, please raise in our social media, and
Yeah.
I will be definitely replying it. Thank you
Yeah.
all. Thank you.
Yeah, so definitely, if still I can see that still questions are popping up, so you can write down in the social media, maybe on this YouTube video as well as in the Telegram group, and from that those questions will be taken up. Okay, okay, so bye from our side. Bye.